Schottky defect is a type of point defect in a crystal lattice where an equal number of cations and anions are missing, maintaining electrical neutrality. This defect is common in ionic crystals like sodium chloride and impacts properties such as density and conductivity. Imagine a crystal lattice as a grid of alternating positive and negative ions. In a Schottky defect, some of these ions are missing from their positions. The total number of missing cations equals the missing anions to maintain charge balance. It reduces the crystal's density because there are fewer ions in the same volume. In sodium chloride, a Schottky defect arises when pairs of sodium Na+ and chloride Cl- ions leave their lattice positions. Schottky defects enhance ionic conductivity because missing ions create pathways for other ions to move through the lattice. This is why materials with Schottky defects are used in applications like solid-state batteries and sensors.
We present a Frenkel defect, so let's keep it simple. Okay, Frenkel defect occurs in ionic solids when a small cation, which is positive ions, moves from its normal position in the crystal lattice and occupies an empty space within the same structure. This defect is common in silver chloride, zinc sulfide, and silver bromide. Since the atoms remain within the crystal, the density does not change, which is constant, but the electrical conductivity increases due to the movement of ions. The defect usually occurs in ionic crystals where there are big differences in ion sizes, like a small ion next to a larger one. For example, in silver chloride or zinc sulfide, the small ion, like silver ion, is more likely to jump out of its normal spot and move to an interstitial position because it can fit into smaller spaces.
Let's move on to planar defect, stacking fault. What is stacking fault? Stacking fault of a type of defect in crystal where the normal stacking pattern of atomic layers is disrupted. This atomic layers is this defect are like a row in how the layers of atom are arranged. The type of stacking fault is intrinsic stacking fault. First, a layer is missing from sequence. For example, is ABC, ABC, and a row ABC, ABC, AC. You can see in example I share in the picture. The second is extrinsic stacking fault. And extra layers is added. For example, ABC, ABC, and arrow ABC, ABC, and B. You can see in the picture the example. The third is twin fault. A mirror arrangement of layer. For example, ABC and CBA BC. Okay, next, why do stacking fault? Wait. Why do stacking fault happen? Deformation, when the material is bent or stretched, and then rapid cooling during crystal growth, mistake in stacking can occur. And then the third, phase change, sudden change in temperature or pressure. The effect of stacking fault is they can make the material stronger by blocking the movement of defect like dislocation, and then in semiconductor they can change electrical or optical properties, and then they sometimes make material less stable in extreme condition.
Grain boundaries is a narrow region between two grains of about 2 to 5 atomic diameter in width contain mismatched atoms from adjacent grain. It is located between separate grain of different orientation. As you can see from the photo in this slide, there are crystal 1 and crystal 2, and in the middle there is grain boundaries. Grain boundaries form due to simultaneously growing crystal meeting each other. It is also a favorable site for nucleation and growth of precipitate. Irregular atom arrangement provide lower atomic packing and higher energy. Atoms are thus able to diffuse more rapidly to form precipitate.